Math 100, lesson 6.5, trig equations. All right, so now we don't just have expressions, we're actually going to have equations, and our directions are going to ask us to solve for the variable. So the values that satisfy a trig equation are its solutions, and sometimes there may be no solution, so that is an option. So one particular example would be if you were asked to solve the sine of x is equal to the square root of 3 over 2. Now, before we do a solve, I'm going to do a simpler question actually. Okay, so let's say we have the sine of x equals the square root of 3 over 2. And my question is going to be, is pi over 6 a solution? So I'm not asking you to find the solutions. I just want to know, is pi over 6 a solution? So I've just stated above that a solution means it must satisfy the equation. So if I took pi over 6 and I found the sine of it, would I get the square root of 3 over 2? And so that is my question. And so you can go to your unit circle, you can use a hand trick, you can use a table to help you figure this out and decide, when we get the sine of pi over 6, is that really the square root of 3 over 2? Okay, if I'm going to the unit circle, pi over 6 is 30 degrees. So at 30 degrees, okay, the sine is the y coordinate if you're on the unit circle, all right? Is the sine the square root of 3 over 2? And it is not. That is not true. Okay, the sine of pi over 6 is 1/2. So pi over 6 is not a solution. All right, so now I'm going to ask you, well, what is the solution? Let's solve that. Okay, we checked pi over 6, and it wasn't the solution. So now I'm saying, okay, well, let's solve for x. In other words, let's find that solution. Now, the easiest way for me would be either the unit circle, or I particularly like the hand trick. But if I'm looking at the unit circle, all right, then what I'm looking for, we know sine is the y coordinate of our ordered pairs. So on the unit circle, you need to find a y coordinate of square root of 3 over 2. Okay, that's what we're looking for. On the unit circle, find a y coordinate of the square root of 3 over 2. Well, on the unit circle, you're going to find that in two places, right? Okay, so if you're looking at your unit circle, we end up with a y coordinate of the square root of 3 over 2 at the x value of pi over 3. Okay, that's in quadrant 1. Well, there is also a value for the y coordinate square root of 3 over 2 in quadrant 2. So where would that be if it's in quadrant 2? Now, what I need to think to myself is, if I'm looking at the unit circle, I can just locate it. If I'm not looking at the unit circle and I'm trying to figure out what would the other one be, then I'm going to say, okay, x is pi minus that reference angle of pi over 3. And so that ends up being 3 pi over 3 minus pi over 3, which is 2 pi over 3. So we actually get two places on the unit circle where the sine is the square root of 3 over 2. Okay, we found two different places. We found x is pi over 3 in quadrant 1, and we found x was 2 pi over 3 in quadrant 2. Now let's say I went around the circle again. Okay, let me just sketch for you a little unit circle here so we can all visualize together. All right, pi over 3 is 60 degrees. All right, so here's pi over 3. And that ordered pair is 1/2 square root of 3 over 2. So that's how I chose that place on my unit circle. And then I chose over here, I have 2 pi over 3. I actually didn't put that in a good place. It's too close to the axis there. And that ordered pair is negative 1/2 positive square root of 3 over 2. All right, so those are the two places that I have just identified, pi over 3 and 2 pi over 3. In quadrant 3 and quadrant 4, it would be a negative y value. Sign is the y value. But here's what I could do. I could go around the circle more than once. Let's say I end up right here, okay? Let's say that's my first angle. Well, if I go all the way around the circle and go back there, that would be a coterminal angle. And I could do that any number of times, stopping at pi over 3 or stopping at 2 pi over 3. So I need to identify all possible answers. So I cannot say that pi over 3 and 2 pi over 3 are all solutions. All solutions would be x is pi over 3 plus however many times around the unit circle you want to go. Okay, if I went around the unit circle one time, then I would say 2 pi times 1. My n value would be 1. If I went around the unit circle twice, then my n value would be 2. So 2 pi times 2 means I go around the circle twice and end up at pi over 3. I do the same thing with the 2 pi over 3. We have to say I can go around the circle however many times. Now, the reason I choose 2 pi is the period of sine is 2 pi. So that's why I'm adding some multiple of 2 pi, because a period is when it begins to repeat values. All right, so all solutions would be these two answers. Now let me show you a different type of question. Let's say this same problem says solve, but it also says, all right, so let me change the directions just a little bit. If the directions state that x has to be between 0 and 2 pi. This means only on the unit circle. We're not going around the circle more than once. Okay, we're just looking at the values on the unit circle. Well, the solutions here would be just pi over 3 and 2 pi over 3. We don't have to worry about the 2 pi n, okay? But if we're looking for all solutions, that's where we have to include the 2 pi n. If the directions tell me that I am in a certain area here, a certain range of x values, then I don't have to worry about the 2 pi n. Okay, let's try some more. All right, so our problems won't always be as straightforward as that one. So let me just give you some direction here. To solve these trig equations, the first thing we want to do, if it is not already done, is to isolate the trig function on one side, if it is not already on a side by itself. The second thing we want to do is then we will solve for the variable. All right, so you want to have your unit circle handy. That is definitely going to be helpful when we're solving these problems. All right, so let's try solve 3 sine of x minus 2 equals 5 sine of x minus 1. So we need to isolate the trig function. There is a trig function on both sides of my equation, and so I don't want to do that. I only want it to be on one side of the equation. All right? So I am going to subtract 3 sine of x from both sides. That leaves me with negative 2 is 2 sine of x minus 1. All right, now I will add 1 to both sides because I need that sine of x to be over there by itself. All right, and then that 2 doesn't need to be there. We are isolating the trig function, so I divide both sides by 2. So I get negative 1/2 is the sine of x. Now, in these directions, I did not tell you that we were in a certain range of x values, so we are going to give all of the places where the sine is equal to negative 1/2. So now we go to our unit circle, and we're looking for a y value of negative 1/2. All right? I'm looking for a y value of negative 1/2. All right, so we've got all these little places on our unit circle. All right, so if my y value is negative 1/2, that is going to be in 2 places. All right, because a smart trig class. Now, I don't have my unit circle sitting here looking at me, but I do know that the sign at negative 1/2 happens in 2 places. Okay, the sign is negative in quadrant 3 and in quadrant 4. So I know I'm going to give those 2 values, and then I'll worry about the plus 2 pi n. All right, so in quadrant 3, all right, here's the way I think myself through this. I know at pi over 6, okay, which would be right here, the ordered pair is square root of 3 over 2, 1/2, which means I have a y value of a positive 1/2. Well, if I use the reference angle, I can find the one that's in quadrant 4. So quadrant 4 would be, all right, 2 pi minus that pi over 6. And that would give me 11 pi over 6. The one that's in quadrant 3, if I think about it like this, how far away would it be from this one? It is pi away. Okay, so if I add pi, so pi over 6 plus pi, and that would give me 7 pi over 6. So in quadrant 3, I get 7 pi over 6, and in quadrant 4, 11 pi over 6. At those 2 places, all right, at those 2 places, so this place is 7 pi over 6, this place is 11 pi over 6, and if you'll notice on your unit circle, your y value in your ordered pair for both of those is negative 1/2. That's what we were looking for. Okay, now it said solve. It did not give me a range, so my solutions are not just 7 pi over 6 and 11 pi over 6. My solutions are x equals 7 pi over 6 plus the period times any multiple. Okay, so n. And then our other answer would be, our other solution would be 11 pi over 6 plus 2 pi n. Remember, we use the period, and then we say we multiply by any integer n. So because that just means we would go around the circle as many times as we want and stop at that same value, coterminal angles. All right, so these would be my solutions. And we do need the 2 pi n's on both of those. All right, I'll give us a range of values on this next one so we can see that happen. All right, so let's solve, and let's do a tangent this time because we haven't done a tangent. All right, so we're solving for x, and x has to be in this range from 0 to 2 pi. So I'm only looking at the unit circle once. I'm not worried about going around it a bunch of times. I'm just going around the unit circle once. All right. So we've got a slight issue here. That says 2x. It doesn't just say x. So for the moment, just to make my life a little easier, I'm going to say, you know what, I'm going to let theta be 2x so that I can look at my problem as just tangent of theta is the square root of 3. Okay, I'll be less confused if I look at it that way. All right, so I look on my unit circle and I'm deciding where is the tangent square root of 3. Now remember, tangent of theta is your y value over your x value. So we're looking for the ordered pairs that when I put y over x, I end up with the square root of 3 over 1. Well, that happens when I have the ordered pairs square root of 3 over 2 over 1/2. So that's what we're looking for, a y value of square root of 3 over 2, an x value of 1/2. I know that happens in the first quadrant at pi over 3. So I know for sure that tangent of theta is the square root of 3 at theta equal to pi over 3. All right, now I know we said we're only going to stay in the unit circle once, but here's the thing. Remember, we substituted theta is 2x. All right, so we do have to take that into account. Now, if I go around the unit circle and I find the next value for tangent, the period of tangent is pi. So this time, that's what I'm adding to pi over 3. All right, I'm adding any multiple of pi. All right, so the next thing that I'm going to do is, we weren't looking for theta. Okay, that was not even in the problem. So now I'm going to go back to what I said. I said theta was 2x. Remember, we said that. I said let it equal that. All right, so if theta is 2x, well, then that means that 2x is pi over 3 plus pi n. All right, now I've got to solve that for x. Our goal here was to solve for the variable. So we got to get x alone. So I'm going to multiply both sides by 1/2. Same thing as dividing by 2. So that leaves me with x is equal to pi over 6 plus pi n divided by 2. Everything gets multiplied by 1/2. All right. So this right here, what I have found is all solutions, which is not what the directions asked for. However, in order to find the ones in the range that they asked me, it's really easier to find all of them and then plug in values for n to make sure that I stay in this range. Remember, we want our x values to be anywhere from 0 to 2 pi. All right, so now we have to decide what n values will make that happen. Well, let's say if n is 0, like we don't go around at all, we just use the first value that we came to. So I don't even have to think myself through that. I could just do the arithmetic and I end up with pi over 6. So there's our first solution in that range. Okay, if n is 1, go through all the steps again. All right, now I have to get a common denominator in order to add these. And so this would become 3 pi over 6. So I get 4 pi over 6. Make sure your answers are always simplified. So that solution would be 2 pi over 3. That is still in the range of values that it asked for. Remember, we're solving for x. If n is 2, I go plug in 2 for the n value. So that leaves me with pi over 6 plus pi. 7 pi over 6. Okay, I'm still in the range, so I'm going to keep going with these n values. I do need a common denominator again. So this will become 9 pi over 6. So that puts me at 10 pi over 6, which is still in that range. Okay, but I do need to simplify. 5 pi over 3. Okay, I have not reached 2 pi yet, so I have to keep going as long as I'm in that range of values. I need a common denominator again, so that would be 12 pi over 6. That gives me 13 pi over 6. Hopefully you realize that that one is bigger than 2 pi, because 12 pi over 6 is 2 pi. So 13 pi over 6, that's too big. Okay, that is no longer in my range of values, because this is greater than 2 pi. And remember, our range said it had to stay between 0 and 2 pi. So our solutions are the values that I found that are in that range. I found pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. We do give the simplified version of our answers. So those are our solutions. That didn't seem like we were going to need that pi in figuring out how many times around the circle, but this one was a little bit harder because we had the tangent of 2x. And so I can't locate that looking at the unit circle. I can't locate those values. Because it said tangent of 2x, and that's not what we're used to seeing on the unit circle. So I needed to plug it in this time. All right, let's try another one. All right, and again, our answers must be in the range 0 to 2 pi. All right, so when I look at this problem, now the first set of directions I gave you of how to solve would be you isolate the trig function on one side. Well, there are two trig functions and they're already on one side, so that part's done. Now you have to be able to recognize. All right, I'm going to just over here to the side in different color, just rewrite this equation. If I said I want the sine of x to equal y, then my equation looks like 2y squared minus 3y plus 1 equals 0. So hopefully you recognize now from your algebra skills that in order to solve this, I must factor. Okay, now I'm not going to keep the y's in there. I just wanted to show you this is a quadratic equation, so we must factor. So I am going to factor here. I'm looking for two things that multiply to give me 2. Those same two things add up to be -3. So that when I plug it into my function, it works out. Now, I don't know how good you are at factoring. I don't know who taught you how to factor. If you need my assistance with factoring, you are going to have to reach out to me because I'm not going to give a factoring lesson here. So I'm going to assume that we can all factor confidently. All right, so 2 sine x times sine x would give me 2 sine x squared. Now I need two numbers to multiply to be +1. Well, that means they both have to be -1. Now, I could just do my FOIL, double check, make sure it is going to give me -3 sine x in the middle, and it is, if I do my FOIL to check it. All right, so once I've got my factors, I set each factor equal to 0. And then I solve. So I move this 1 over, and then I divide both sides by 2, so sine is 1/2. And over here on this one, I just have to move that 1 over. So now we're looking at our unit circle, okay? This does not say sine 2x, so we can just look at the unit circle. All right, now we're trying to find the x values between 0 and 2 pi, so we're only on the unit circle. And we're looking for y values of 1/2. And so we need to decide, where does that happen? Well, it happens twice for 1/2 over here. The sign is 1/2 in 2 places. That happens in quadrant 1. And if you'll look down in your unit circle, it also happens in quadrant 2. Okay, so in quadrant 1 at pi over 6, the y value is 1/2. So the sine of pi over 6 is 1/2. In the second quadrant, which would be pi minus that pi over 6, so at 5 pi over 6, the sine is 1/2. So there's 2 solutions, pi over 6 and 5 pi over 6. Now the sine is 1, so on your unit circle, at what radian value is the sine 1, the y value 1? Well, that happens at pi over 2, and that's the only place it happens. So my solutions, I have 3 of them. They are pi over 6, pi over 2, and 5 pi over 6. There they are, just those 3 solutions. I can actually see those on the unit circle. Now again, if factoring is a bit of an issue for you, please reach out to me individually so I can help you with factoring. So I've got a couple more. I just want to try to show you a few different kinds of problems, so you'll be prepared. Okay, so this time we're solving the sine of x times the tangent of x equals the sine of x. Okay, so remember, our direction said isolate the trig function on one side. Well, I've got trig functions on both sides. So to move that, I am going to take this sine of x right here, and I'm going to move it to the other side by subtracting. Now, a big mistake, big mistake that I see people make is to divide both sides by sine. Do not do that. The reason why, if you divide both sides by sine x, then sine x, what's going to happen? It's completely gone, and we've eliminated some answer choices. Okay, so do not do that. That is not how we solve equations. We should not divide something out. All right, so we are going to move it to the left side by subtracting. All right, I don't really like that I wrote it like that. Let's just subtract it from both sides. Okay, so sine x times tangent of x minus the sine of x leaves me with a 0 over here when I subtract it on the right side. All right, so now it is equal to 0, so I've done that. I've isolated it on one side at least. Now, there's no way I can put those together. They're not like terms. You cannot actually subtract. But what I can do is factor out a sine of x. That would leave me with a tangent of x minus 1. Now I can set each factor equal to 0. Okay, so I need to add 1 to both sides of this one. All right, so I'm looking on my unit circle, and I'm deciding where is the sine equal to 0, so where's the y value of my ordered pair 0? Okay, that happens in 2 places. That happens at x equals 0, and that also happens at x equals pi. So if you look at the ordered pairs at 0 and at pi, the y value is 0 for both of those. Okay. Now we're looking for where is the tangent 1. Remember, tangent is the y value over the x value. Where is the tangent 1? Well, that happens twice. That happens in quadrant 1 and it happens in quadrant 3. Okay, in quadrant 1, that would be the pi over 4. Okay, if I take the y value, put it over the x value, okay, remember that square root of 2 over 2 over square root of 2 over 2, and I get 1. Okay, that happens at pi over 4. And now I have to decide in quadrant 3, I know it happens again in quadrant 3 when I'm looking at, I have those same ordered pairs. I would have a negative divided by negative, which would still give me a positive 1. So if I find the one in quadrant 3, that just means I add pi, and I would end up with 5 pi over 4. And that would tell me what the radians in quadrant 3. So my solutions, I have 3 of them. I have 4 of them. They are 0, pi over 4, pi, and 5 pi over 4. 4 solutions. All of those are in that range of values between 0 and 2 pi. All right. One more example and we will be done. Definitely want to have your unit circle beside you when you are working these types of problems. It is so much easier. Calculator, not so much help. In fact, you need to be able to show me without your calculator. Okay, so we're still solving, so we've got to get x alone. The trig functions are already on one side, so that's good news. So now I just have to figure out what am I going to do with this. Can't do any factoring here, but I do recognize that cosine of 2x, well, that's one of those double angle formulas. Okay, that's one of those double angle formulas. So, might want to pull out your double angle formulas. And remember, for cosine, there were 3 different options for you to use for cosine of 2x. I'm going to use the one that involves sine because I have that little sine x right beside it. Okay, right here in my equation. All right, so that's why I'm choosing that one. So now my equation is completely in sine. All right. I really don't need those parentheses, so I'm going to just take them out. They're not doing anything for me. All right. Now, this is not in descending order, so I'm going to put it in descending order. The sine squared x should come first, then the sine x, and then the constant function 1. All right. So again, this is one of those where we are going to have to factor like we did in example 3. Okay, this is a quadratic equation. Now, the problem with factoring this one is that leading term is -2, and we don't like to factor with that being -2. So I'm going to multiply both sides, first of all, by -1. Because I don't like that first term to be negative when I get ready to factor. So positive 2x squared x minus the sine of x minus 1 is still just 0. All right, now I'm ready to factor. Again, if you have questions on factoring, please let me know. All right, so 2 sine of x times the sine of x will give me 2 sine squared x. And this time, when I multiply, I should get -1. So one of these has to be positive and one of them has to be negative. You do have to decide which one because your middle term should give you a negative sine x. So when I check with my FOIL, I need this to give me a negative value, because then when I add this, I would get a positive if it was the other way around. All right, so negative 2 sine x plus sine x will give me the negative sine x that I'm looking for. So now that I've found my factors, I set each factor equal to 0 and solve. Okay, so I'm going to move this 1 and then divide by this 2. All I have to do on this one is move the 1 by adding. All right, now we were asked to find x values from 0 to 2 pi. So we are looking on our unit circle, and we're trying to decide where is the sign -1/2. So you're looking for any ordered pair on the unit circle that has a y value of -1/2. Well, that happens in 2 places on your unit circle. It happens in quadrant 3, and it happens in quadrant 4. In quadrant 3, that would be 7 pi over 6. All right, in quadrant 4, it would be 11 pi over 6. I just use reference angles to find it because I don't have my unit circle sitting in front of me. Okay, and now we have to decide where on the unit circle is the y value 1. Where's the sign 1? Well, that only happens in one place, and that happens at pi over 2. So my solutions, there are 3 of them. They are pi over 2, 7 pi over 6, and 11 pi over 6. So make sure when you work these, you have your unit circle beside you. It might be useful to have your double angle and your half angle in case those show up also. And please let me know if you've got any questions about factoring or any of the other issues here. This is the last section in this chapter. So when you're finished with this, you'll need to go back and practice everything because we're getting ready for our test.